JMP Pro, the advanced analytics version of JMP, lets scientists and engineers build better models, drive faster innovation, and solve more complex and difficult problems. Bayesian optimization is a new platform in JMP Pro 19 that promises to accelerate innovation. Functional Data Explorer introduces automated baseline correction and parametric peak modeling to extract high-quality information from difficult-to-resolve spectral data in analytical method development. We've also added causal inference, propensity scoring, and propensity score matching in the fit model platform, mixed model-based stability analysis, and there are many enhancements to generalized linear mixed models. To talk about some of the highlights, I'd like to hand it over to Chris Gottwald, JMP's Chief Data Scientist. Chris?
Thank you, Mia. Today, I will be introducing to you some of the key new capabilities coming in JMP Pro 19, the causal treatment platform, the mixed models additions of stability analysis and ordinal responses, automatic baseline correction and parametric peak modeling in the Functional Data Explorer, and the new Bayesian optimization platform. The first new platform I'll introduce is causal treatment. One of the first things that everybody learns in statistics is that correlation is not causation. For example, look at this scatter plot of age by height from the big class data set. Some relationship between age and height is visually apparent. We can fit a model adjusting for other terms, and the p-value for height is highly significant. But everybody knows that increasing height does not increase age. Now, JMP is already very heavily used for making causal statements from data. That's what design of experiments is all about. Long ago, George Box said, "To find out what happens when you change something, it is necessary to change it." But there are many questions we simply can't answer with DOE, especially when the data is observational or when working with human subjects. An obvious example is that we can't give people water with lead in it to see what happens. But we have come a long way since George Box's day, and rigorous methods have been developed that can tease causality from observational data. We have put some of the best and most robust of these methods into the new causal treatment platform. You declare your causal treatment variable and the response you are studying. Like any fit model platform, you declare a model for the response, but also for the treatment variable. The treatment model creates what are called propensity scores that are used to adjust the response model to make it capable of rigorously testing causal claims. In this case, we try to identify if an intervention lowered people's systolic blood pressure. There's a lot of statistical machinery in the background, but your causally adjusted inference is front and center when you launch the platform. In this case, it's shown that the treatment appears to lower patients' systolic blood pressure, even after adjusting for possibly confounding other variables like family history and whether the patient has insurance coverage. There are many tools in the platform to check the validity of the necessary assumptions needed to make these strong causal claims. JMP Pro has really come a long way to make mixed models accessible to researchers that would prefer a JMP user interface over using a programming language. And even more so with the addition of ordinal responses so that Likert scale survey data can be analyzed in the platform. We've also added a stability analysis module for determining expiration dates. How many products can you think of that come with expiration dates? Many things that all of us depend on every day. Wouldn't you want the people making those things to use rigorous methods for determining shelf life? There's a lot of debate and different ideas about how to do this, but the ones that have the most evidence behind them all treat batch as having its own random slope and intercept. The module we've created offers different approaches for calculating expiration dates, like ones based on quantiles and tolerance intervals of the crossing time distribution. In JMP Pro 19, in the Functional Data Explorer, we've made strides to make it more useful for applications within analytical chemistry with the addition of automated baseline correction methods like SNP, as well as parametric peak modeling. This is data from a definitive screening design with a chromatographic response. We want to estimate the areas under the curve of each peak and design a buffer that allows us to separate the product from the impurities before it gets put into pills. To do this, we remove the baseline using the new baseline correction tool. We'll apply the SNP method, but we have other options as well. SNP did a good job, and we can save the corrected spectra back out. So we started here and SNP'd our way here. Then we go into the peak finding tool. A sum of Gaussians model is fit to the data. Then we go to the summaries and save them out for the next stage of the analysis, saving the AUCs and the resolutions so they can be analyzed by the generalized regression platform in JMP Pro. One of the most exciting new platforms in JMP Pro 19 is the Bayesian optimization platform. Before going into it, first let's think about how JMP users optimize products and processes in JMP. We collect some data, either with a starting design or pulling data from a database. It can take a lot of time and resources to get enough data that we can trust the models that we're working with. But once we do trust them, we go into the profiler to optimize those models. Now, wouldn't it be faster if we could use the profiler earlier in that process to have it make use of all the information in the data as well as our project goals early on when we have as few as maybe 2 data points and have the profiler recommend combinations to try next that simultaneously improve model fit while driving us towards our solution? The framework that makes that possible is called Bayesian optimization, an integrated modeling and data augmentation scheme that learns from the responses as we acquire more information. The name sounds fancy, but the barrier to entry knowledge-wise is a lot lower than you might think. There are no hypothesis tests, there's no p-values, there's no need to specify interactions or curvature terms because the response surface emerges directly from the data itself. If the data have aliased effects or multicollinearity, Bayesian optimization will just tell us an intelligent way to break that data defect at the next step. Many of the complexities of dealing with mixtures and constrained regions also just disappear with Bayesian optimization. Here's a simple example using a simulated version of the familiar tire tread sample data set. We want to maximize the abrasion response while matching a target on the elong one by adjusting 3 input variables. The original data has 20 runs, but here we will start with just 5 runs from a Latin hypercube design. We bring up the platform and we see that the abrasion response is fitting poorly. We also see a run chart of the observed desirability scores. They are all near 0, so none of these starting runs are anywhere close to solving our problem. The platform automatically recommends a space filling run to improve the model fit. We can save the recommended run and proceed. When we get the response for that new run, we find that it improves model fit and also has superior response values. I'll quickly go through the next few iterations, but as we go, watch the run chart that tracks our progress. The platform starts replicating at the 13th run. This indicates that we have solved the optimization problem in 7 fewer runs than the original data set. This is very promising. To all of you familiar with modeling in JMP, the best way to describe this platform is that it is a Bayesian optimization-based augmentation built directly from the JMP profiler in all its generality. It directly inherits the ability to do response-guided, goal-oriented run selection for any continuous response optimization problem solvable by the profiler. This includes multiple responses, constrained input regions, disallowed combinations, arbitrary combinations of continuous, ordinal, and nominal variables. You can also lock factors and change the ranges of variables by adjusting the axis, and then just ask for where to look next given the new input space. By working directly with the JMP profiler and improved algorithms for Gaussian process models, we've eliminated as much of the cumbersome statistical machinery that gets between you and the solution to your product or process innovation as much as we possibly can. Thank you very much.